Thank you. So Jim, you're up.
Okay, I'll get on the screen share here. Okay, everybody seeing that? Okay. Now this is a continuation. Well, last time I did 2 sessions on the T1, the FCC rules, basically. This we're getting into. This is a fairly short section, only two parts to it: T1A and T4A and T4B. Amateur radio practices. Again, not a lot of theory in these questions, so we'll be able to go through them fairly quickly. 12. So in the scheme of things for a technician exam, there will be 1 question out of each of these 2 elements on the exam, and there are 12 possibilities in each section. So, question 1, which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? Well, the main thing to remember is, amateur radio runs on 12 volts, 12 volts DC. So that immediately eliminates the 224 volts. And if you're, 4 amps isn't really a lot of draw. And if you look at any sort of transceiver, mobile or otherwise, typically it'll tell you to, you're going to need a 12 to 15 amp power supply for this kind of a receiver, a transceiver. So the answer is 13.8. Again, that's the any power supply gets pretty much always going to have 13.8 as the rated voltage. Question 2, which of the following should be considered when selecting an accessory SWR meter? SWR meter is standing wave ratio to measure how well your antenna is performing. And what you want to do in using an SWR meter is for a specific frequency. You're wanting to see if you've got your antenna tuned for optimum performance on a specific frequency. And so if you look at all the answers, there's only one that has frequency in it. So frequency and power level at which the measurements will be made. 3, why are short heavy gauge wires used for a transceiver's DC power connection? Well, the shorter the better in this case, to minimize the voltage drop when transmitting, so less line loss between the power supply and the transceiver. 4, how are the transceiver audio and input and output connected to a station configured to operate using FT8? Now, I think in some of the questions they get into some of the digital things more often, but what you need to know is FT8 is a very popular digital mode, particularly in HF, and it's a computer generated mode, and in this case you need software. So the answer is WSSJ SJTX software. This is the software you need in your computer to operate in the FT8 mode. And FT stands for the 2 originators, developers of this mode, Frank and Taylor. And John Taylor was a Nobel Prize winner. So it's very popular these days. What should an RF power meter, where should an RF power meter be installed? Well, you're trying to figure out how much of the power coming out of your transceiver is actually getting to on its way to the antenna. So in the feed line between the transmitter and the antenna. And this is a little graphic out of the syllabus. 6, what signals are used in a computer radio interface for a digital mode operation? Okay, digital, basically you're converting radio signals into sound. And so key there is audio. Audio transmit, audio receive, and transmitter keying. The other ones don't really fit. Which of the following connections is made between a computer and a transceiver to use computer software that is operating digital modes? Well, this one can be confusing. I'm not an electrical engineer, and I've always had trouble with electrical engineering because there are too many pluses and minuses, forward and reverse, that sort of thing. So I was always getting confused. But in this case, you remember we're talking about digital sound speaker, and in this case, I would just remember line in is the correct answer. So again, the key, if you're trying to think through it, digital has to do with sound when you're converting radio signal. Which of the following conductors is preferred for bonding in RF? Conductors is a key word here. What's the best conductor? Copper. And we've got two copper answers. Copper braid removed from a coax cable. That seems kind of crazy to disassemble a coax cable to get the copper braid. So the flat copper strap is the answer. And this is the picture out of the syllabus. 9, how can we determine the length of time that equipment can be powered from a battery? Now, all batteries, storage batteries, are rated in amp hours. And that pretty much gives you the answer. The thing when you're actually doing the calculation too is the average amp hour rating is what you're looking at, the average current draw. And so the only answer is amp hours. So if, for example, you've got a 12 amp hour battery and your average current draw is 6, you can run your radio for 2 hours. 10, what function is performed with a transceiver and a digital mode hotspot? The digital modes, a lot of people use them. I think there's some questions on DMR, digital mobile radio, in here. But a lot of people use a hotspot. A hotspot is a way to get into the DMR system or any other digital internet-based system if you can't reach the receiver from your location. So it's just sort of a helper. It enables you to connect using digital voice or data systems via the internet. So your radio goes to the hotspot, hotspot connects to the system you want to get into, DMR, some of the other ones, and that's where it fits in. And the other ones, well, no, they don't really fit. 11, where should the negative power return of a mobile transceiver be connected to a vehicle, in a vehicle? Now, we know that we're going to be operating on 12 volt, the car is on 12 volts, and so that seems to be the pretty logical connection to the 12 volt battery chassis ground. So you're on the same ground. And 12, what is an electronic keyer? Well, what's a key? A key, think about Morse code keys. Clickety click click. The device that assists in the manual sending of Morse code. So that's pretty straightforward if you just think, what is a key for? So that's the first half. And moving on to part B, or section B. What are the effects of excessive microphone gain on SSB transmissions? SSB single sideband. And a lot of the questions, whenever you see something like excessive or whatever, the answer is usually distortion. It's going to distort the audio if you sort of have excessive mic gain. 2, which of the following is used to enter a transceiver's operating frequency? Generally, in a transceiver, you're going to have 2 operating modes. You either operate out of the memory, since they've all got a memory in them these days, or you're going to operate in what we call VFO mode, variable frequency operator, which is the tuning dial on your radio. And there's only one answer that has VFO in it, or you can also do that with a keypad. You know, a lot of the mics have a little keypad on them too. So in most radios these days, you can either tune the frequency with the VFO dial, VFO knob, or punch it in from the keypad, which is indeed the correct answer. 3, how is the squelch adjusted so that a weak FM signal can be heard? Now, the squelch is there so that it can, under normal conditions, what it does is it screens out a lot of noise. If you only want to hear the strong stations and not get lost in a lot of noise, then you set the squelch threshold so that you only hear the strong stations. But this says adjusted so that a weak FM station can be heard. Well, we don't want to screen out the strong station, so we want to set the squelch threshold so that the receiver audio is on all the time. Otherwise, it's not screening out anything, so that you can pick up those weak FM stations if possible. 4, what's the best way to enable quick access to your favorite frequency or channel on your transceiver? Well, we answered this 2 questions ago. You've got VFO as one way to get to the frequency you want, or you can pull it out of memory. So store the frequencies you want in your memory. And most the radios, the transceivers you're going to get these days have up to 1,000 at least memory channels. So you can store basically anything you want. The frequency list we use in our club has about 100 frequencies. Now, in reality, only need maybe a dozen of them, depending on what sort of things you're doing. But generally, you want to have in your memory storage those frequently used channels, repeaters in your area. What is the scanning function? What does the scanning function of an FM transceiver do? Well, where have you heard about scanners before? Police scanners. A lot of people like to get police scanners so they can hear what's going on in the public service, police, and fire frequencies. And what does the scanner do? It scans across the frequencies to see if there's anything of interest out there. And it's exactly what the scanning function does on your transceiver. It tunes through, and you can set where you want it to scan too. Others, you can say, I'd like it to scan from UHF frequencies from 440 to 445 or something like that. But then if somebody comes on, then it'll pick it up when you're scanning. 6, which of the following controls could be used if a voice pitch of a single sideband signal returning to your CQ call seems too high or too low? Well, this is another one that unless you read up, you might not know. You could think about tone squelch, but no, tone squelch is limiting things. And anyway, the answer is RIT or a clarifier. RIT means receiver incremental tuning, sort of a fine tuning for your radio. What does the DMR code plug contain? Okay, there's DMR is a computer. In other words, your little computer you've got in your radio, your DMR radio. One aspect of it is the code plug, what's called the code plug. And that's what stores, similar to what you're storing in your memory channels for a transceiver. The code plug stores all the access information for repeaters and talk groups, a particular group that you might want to tune into for your radio. The other element that's of software involved with a DMR radio is item D, which isn't this particular question, and that's the firmware. So you're always talking about people saying, well, I need to update the firmware on my radio because I've only got version 3.8 and it should be 3.9, or I need to update my code plug because I don't have the latest information on repeaters in there. The other thing that the code plug has, which in a DMR, it'll pop up call sign of whoever's talking to you on the DMR radio. And that's all in a big database. And all those can be stored in your little handheld or mobile DMR radio. 8, what's the advantage of having multiple receive bandwidth choices in a multi-mode transceiver? A multi-mode transceiver is one that you can do. For example, you might be both DMR and analog, normal UHF, VHF. And the answer is it allows you to, and some of the those modes have different bandwidths, 50, 25, 12.5, depending on what the mode is. And so having multiple choices allows you to sort of target or narrow the match your radio with the or the bandwidth with the mode. How is a specific group of stations selected in the digital voice transceiver? Again, think back to the question we just had on DMR. All of the code, for example, talk groups are identified by a code. You also have codes if you're getting into what we call IRLP, the Internet Repeater Linking Project. But in this case, if we think about the group's identification, think of a talk group. For example, our local DMR net operates on talk group 31538. So all of these, there's a lot of identification codes, and that gets you into the right talk group. Okay, which of the following transceiver filter bandwidths provides the best signal to noise ratio for SSB? I think this is a question that, unless you're very knowledgeable in radio and electrical engineering, you just have to remember what the answer is, which is 2400 Hertz. Here's the explanation in the syllabus, and I'm sure a lot of other more experienced or more knowledgeable hams will understand this, but I didn't. So my suggestion is just remember this question, when it pops up on your exam, 2400 is the answer. 11, which of the following must be programmed into a D-Star digital transceiver before transmitting? Okay, think about two things here. One, what does the FCC always require that you do? One, identify yourself. And that's the answer. D-Star is another digital mode, but you've got to have your call sign in there. And last one here is what is the result of tuning an FM receiver above or below a signal's frequency? This is similar. Remember the other one we had about if something's a little off, distortion is usually the answer. It is in this case. So if you're a little off frequency, then you're going to get a distorted signal. And that's all we've got. So any questions on that in particular? Again, those are pretty straightforward, not a lot of theory behind it. I will stop sharing. And ready for Marty.
Okay. We share here.
Yeah, Marty, go ahead.
Yep. So can you see that? Can you see that?
It's good.
Screen? Pardon?
We got you.
Okay. Set them on the wrong screen. We stop share. This is the dead screen. Okay, there we go. Anyway, this is element 6, electronic and electrical components. And I'm Marty, I'm WA7MJL, I'm from Bellingham, Washington, and Here's my email in case you need to send me a question. Okay, there are 4 groups of questions in this section. And there are 12 questions in each of the sections except for the last one, which only has 11. And on the test, you'll generally get 1 question out of each of these groups. So let's start at the top here. What electrical component opposes the flow of current in a DC circuit? Well, remember back when you were doing Ohm's law, it is resistance, and what has resistance? A resistor. Number 2, A2, what type of component is often used as an adjustable volume control? Well, just think back to your AM radio on the volume control. When you adjust the volume, you're actually turning a variable resistor, which is also called a potentiometer. And A3, what parameter is controlled by a potentiometer? Well, it's just a variable resistor, so it's resistance. And in these questions, there's not a lot of theory. It's basically just an understanding of how these various components work, and a lot of memorization. A4, what electrical component stores energy in an electric field? Well, a capacitor stores energy in an electric field. Compared, well, I'll get in a second. A5, what type of electrical component consists of a conductive surface separated by an insulator? Well, if you look at the diagram for a capacitor, you'll see there is a conductor on the top, a conductor on the bottom, and an insulator between them, and they're rolled up. And it looked like this, but it is a capacitor. Conversely to a capacitor, question A6, what type of electrical component stores energy in a magnetic field? Well, if you think about what an inductor is basically a coil of wire. And that creates a magnetic field when there's current passing through it. So the answer is C, inductor. Question A7, again, what electrical component is typically constructed of a coil of wire? Again, that would be an inductor. Question A08, what is the function of a single pole double throw SPDT switch? Well, if you look at the schematic for one, you'll see that it is a switch that lets you switch between 2 different circuits as you throw the switch back and forth. So it's answer C. A single circuit is switched between one of two other circuits. Question A09, what electrical component is used to protect other circuit components from overloads? Well, just as your circuit breakers in your house oftentimes protect you from circuit overloads in your house, you could have a circuit breaker in a radio, but most don't. They use fuses. So answer A is correct. Question A10. Which of the following battery which of the following battery chemistries is rechargeable? Well, if you look at the list of names, all of these kind of remind you of things you might have. Most of us don't have a nickel metal hydride battery. A lot of us have lithium ion batteries. A lot of us have lead acid batteries in our car. And the guesstimate answer is yes, all of these choices are correct. And the converse question is question 11. Which of the battery chemistries are not rechargeable? Well, a carbon zinc battery is a standard battery you might put in your flashlight or into a television tuner, and they're not rechargeable. An AA cell, a D cell, a C cell. Anyway, those are all carbon zinc batteries, and they're not rechargeable. Okay, now we get some pictures. Question A12. What type of switch is represented by component 3 in figure T2? You'll see that right there. You can tell pretty easily it's a switch, and it's only got one throw on and off. So that's a single pole, single throw switch. Yeah, that takes us to section 6B. Semiconductors, basic principles and applications of solid state devices, diodes and transformers, and transistors, sorry. Anyway, here's one basically you're just going to have to memorize unless you're an electrical engineer. Which is true about the forward voltage drop of a diode? A, it is lower in some diode types than others. What they mean by that is there are a couple of kinds of diodes that are commonly used, a regular diode and a Zener diode. And a Zener diode has a lower voltage drop. Also, a Schottky diode also has a lower voltage drop than a regular diode. But basically, you're just going to have to remember it's the answer is lower in some diode types than in others. B02, what electronic component allows current to flow in one direction only? Well, a diode allows current to flow in one direction only. And you notice here is the schematic for a diode, and there's kind of a picture of a diode. B3, which of these components can be used as an electronic switch? Well, you know that a potentiometer is just a resistor. And from the name, you might guess that a thermistor is also a kind of resistor. One is actually sensitive to temperature. So it narrows it down to a varistor and a transistor. I really don't know what a varistor is, but I do know about transistors, and transistor happens to be the answer. Okay, which of the following components can consist of 3 regions of semiconductor material? Well, if you look at a diagram of a transistor, it has 3 kinds of semiconductor material either positive, negative, positive, or negative, positive, negative type. And so the answer to that is B, transistor. Now there's another kind of transistor that has a lot of the same capabilities of a regular transistor, but it works better at higher frequencies. And anyway, it has different names for the three connectors to it compared to a regular transistor. A regular transistor has an emitter, a base, and a collector, while a field effect transistor has a source, a gate, and a drain. So the answer is B, field effect transistor. Question B06. How is the cathode lead of a semiconductor diode often marked on the package? Well, semiconductor diodes, you want to connect with the proper polarity for the circuit that you're working on. And you need to know which end of the diode is the cathode. And almost all semiconductor diodes have a band printed on the end of the diode that is the cathode. So it's B with a stripe. Here's one you're basically going to have to just remember. What causes a light emitting diode and LED to emit light? A forward current through that LED. B08, what does the abbreviation FET stand for? Well, the only circuit component we've talked about that has FET in the name is a field effect transistor. And question B09, what are the names for the electrodes of a diode? And this another one you're just going to have to remember. It's an anode and a cathode, and the cathode end is marked with a line generally. Question B10, which of the following can provide power gain? Well, transformers adjust voltages. Reactors have nothing to do with gain. Resistors have to do with current. So the answer is B, transistor. And over here is a little diagram of a schematic of an amplifier with a signal coming in to the base of the transistor, and the output is an amplified version of that signal. Question B11, what is the term that describes a device's ability to amplify a signal? You notice here is the input in an amplifier circuit. Here is the output. You notice that there is a gain in signal strength. So the answer is gain. B12, what are the names of electrodes on a bipolar junction transistor? And they are the collector, the base, and the emitter. And depending on if it's a PNP transistor or an NPN transistor, the schematic diagrams changes slightly with where the little arrow is. But the answer in both cases is B, emitter, base, and collector. That takes us to section C of unit 6, circuit diagrams, use of schematics, basic structure, schematic symbols of basic components. So the first question is pretty obvious since we're talking about schematics. What is the name of an electrical wiring diagram that uses standard component symbols? Well, it's a schematic. And an example of one is right here. Question C02, what is component 1 in figure T1? Well, you look and find figure 1. Well, what is that? Oh, that's a resistor. It has the standard schematic diagram symbol for a resistor. What is a component 2 in figure T1? Well, component 2, okay, that is a second element that's got 3 connections. About the only circuit element, about the only device that has three connections to it is a transistor. C04, what is component 3 in T01? Well, okay, there's, and that, well, what is that? Oh, that looks kind of like a light bulb. So that is actually what it is. It's a lamp. Question C05, what is component 4 in T1? Well, look around. Ah, okay, here. There's component 4. What does that look like? Well, that's the schematic symbol for a battery. So the answer is D, battery in this case. Oh, and one thing I might note is in the test, they'll actually rearrange these oftentimes. So don't remember, oh, C05 is D. Remember, C05 is battery. Question C06, what is a component 6 in T2? You look around, find C6. There's C6. What is that a schematic symbol for? That's a schematic symbol for a capacitor. Remember, a capacitor is a component formed with 2 plates separated by a dielectric. C07, what is component 8 in drawing T2? So you find 8. Ah, there's 8. Oh, you say, oh, that's a diode symbol. But I look over in the answers and I don't have a straight diode, but I have a light emitting diode, okay, as a possible answer. And if you look at the schematic symbol, you've got these 2 little lightning bolts coming off the side. That represents light. So the answer is D, a light emitting diode. What is component 9? Okay, you find component 9. That's a resistor with, oh, that is an adjustable resistor, a variable resistor. So I can find, oh yeah, there it is. There's the answer there, a variable resistor. And again, what is component 4 in figure T2? There's 4. What is that? Well, you can say, well, that's a couple of inductors with some lines between them. And you say, oh, yeah, that's a transformer to adjust the voltage. For example, this might be 120 volts coming in on this side and 12 volts coming out on this side. So the answer is transformer. What is component number 3 in figure T3? And I'll say, okay, we have symbol here, that's an inductor, but there is a little circuit on it that indicate, or line on it that indicates that it's adjustable or variable. So I can say, oh, that's a variable in inductor. And question C11, what is component 4 in figure T3? And say, okay, oh, that's an antenna. So you have a tune circuit here. And this is actually a tuning circuit for an antenna to match the load of, to match the device over here to the impedance of the antenna. So this is an antenna. C12, which of the following is accurately represented in an electrical schematic? Well, look at this one. I mean, this tells you what's in the circuit, but it really doesn't tell you how they're arranged on a circuit board, which can look a lot like this. So it really doesn't tell you the lengths of the wires. It doesn't tell you what they look like, but it does tell you how they're connected by these various leads you can see here. So the answer is C, a component of connections. Which takes us to section 6D, component functions, rectifiers, relays, voltage regulators, meters, indicators, integrated circuits, transformers, resonance circuits, and shielding. An awful lot of stuff to cram into one little section. In the tech license requirements, you really don't need to know how circuits work, but you do need to know oftentimes when you're reading about radio communications, at least what they mean when they mention certain types of circuit components. So question D01. Which of the following devices or circuits changes an alternating current into a varying direct current signal? Well, transformers can adjust the voltage, but it's only AC voltage, so it can't be the answer because you're talking about direct current. An amplifier can adjust the gain of a signal, which is also an AC signal, so that's not direct current. No idea what a reflector might be, so the answer is a rectifier. What is a relay? Question 2. Well, what do you use a relays for? To use a signal to control a switch. Here is a picture of a relay. Here is a schematic diagram of how one might work. As current is applied, the switch here goes from the top position to the bottom position. So anyway, it's a switch that is controlled electrically, answer A, and electrical a control switch. As you put voltage on these wires, it actually causes the relay to engage. Question D03. Which of the following is a reason to use shielded wire? Well, answer A says to decrease the resistance. I can't imagine how shielding would help that. Question answer B is to increase the current carrying capability. I can imagine how shielding would help that. But answer C, why would you shield something? To prevent something else from getting to it. So the answer is actually C, to prevent coupling of wanted signals to go to or from the wire. So in a coax cable, for example, you've got a shield around it to contain the RF signal that is in the wire. Question D04. Which of the following displays an electrical quantity as a numeric value? Well, again, a potentiometer is just a variable resistor. A transistor adjusts gain or acts as a switch. A relay is just a switch. So obviously the answer is a meter. Can be analog, can be digital. What type of circuit, question 5, what type of circuit controls the amount of voltage from a power supply? Well, if you look at the answers, the only one that seems to indicate some kind of regulation is answer A regulator, which is the correct answer in this case. Question D06. What component changes 120 volts AC to a lower power voltage, a lower AC voltage for other uses? Well, a variable capacitor just adjusts the capacity, the capacitance of the device, which doesn't seem to do anything with voltage. A transistor, again, can act as a switch or provide gain. A diode simply regulates the voltage so that it goes in one direction only. It's not going to change the voltage. So a transformer is used to adjust or to change voltages. And besides going to a lower voltage, you can have transformers that actually go to a higher voltage also. D07. Which of the following is commonly used as a visual indicator? Well, a bipolar transistor is used to act as a switch or to adjust gain of a circuit. The Zener diode controls voltage in a circuit. A field effect transistor, again, can act as a switch or as a method of gain. So, light emitting diode, LED. Examples. I'm getting short here. D08. Which of the following is combined with an inductor to make a resonant circuit? If you look at the examples, there is an inductor, there's a capacitor, there's an inductor, there is a capacitor. The answer is a capacitor. D09. What is the name of a device that combines several semiconductors or other components into one package? Well, transducer and relay and transformer are obviously wrong, so it's an integrated circuit. And examples here, some circuits, you can usually tell them in schematics because they have at least 8 or 9 leads going in. If you look at those in computer CPU chips, you can have hundreds of leads coming in. D10, what is the function of component 2 in your T1? You look at that. That's a transistor. What do you do with a transistor? It doesn't give off light. It doesn't supply energy, but it is used to control the flow of current. It can act as a switch or provide gain. D11. Which of the following is a resonant or tuned circuit? You saw this diagram just a minute ago. And here's an inductor and a capacitor, an inductor and a capacitor. So it's a circuit that has an inductor and a capacitor in series or parallel. And that's the end of the session. Any questions? Anybody out there?
Yeah, it's a little confusing, so it looks like we need to actually like learn the different diagrams of those little codes, or whatever those.
Yeah, you do. You need to actually look at the examples that you can see online and learn the actual symbols for the 2 or 3 dozen possible circuits that are in, or devices that are in a schematic diagram.
Thank you.
If Dan, if you send me an email, I can send you a sheet that has all of those circuits on, or all of those schematic symbols on it.
Kathy, you still with us?
Yeah, anybody else?
Kathy, are you lost?
No, I'm here.
Follow that all?
I'm gonna have to do some memorization, but seeing the schematics definitely helped. So I started recognizing the squiggly line as the resistor and some of the other parts.
Yes, Steve, I can send you a sheet that has the commonly used schematic symbols on it. You can send out to the class members.
That would be great. Or you could just send it all to, because Kathy, I know everybody has her email. If you want to
Okay.
send it to her. Just so happens we live in the same house, but I'm sort of not in the same room.
Okay. Any other questions? Okay, it's back to you, Steve.
Well, it's up to Doug. Doug, we're 14 seconds, or excuse me, 20 seconds early. Is it okay to start?
I'm ready to start anytime.
Okay, go for it.
Okay. Well, let me share my screen here. If I can find it. And I'm not seeing my screen. Hang on here just a second. Oh, there it is.
Is that a grief kit off to your left there?
Everybody see that?
Got it. But you need to be into presentation mode.
Affirmative.
Okay. Let me get in presentation mode.
Be end of the slideshow menu at the top.
Yes. Are you talking about PowerPoint?
Yeah, click from the beginning, the first button at the top left.
From the beginning. Okay, there we go.
Perfect,
Okay, you got it? See it?
perfect.
Okay, good. Thank you. Thanks for that. So my name's Doug Blankstead, K7CDF. I'm in Seebeck, Washington. I coordinate the Kitsap Auxiliary Radio Service amateurs in support of Kitsap County Department of Emergency Management. And I have been in emergency services since 1970, which is really dating myself. So I kind of grew up in ICS when it came to when it started growing in California, as I was a state fire agency person at that time. So anyway, so I'm just going to do a quick overview, talk a little bit about the NIMS ICS and a couple definitions. ICS is the Incident Command System, and it's basically what differentiates it from the National Incident Management System is that the ICS is an on-scene incident management concept, as it says there, and the NIMS is an overarching program that pretty much takes care of all the components you see there: preparedness, communications, information, and so on and so forth. And it basically is pulling everything together to try to get make sure everybody is on the same page when it comes to incident management. And ICS is a component of NIMS. And a little bit of history. First, there was a large fire organization, and that was based on military. After World War II, there was a lot of folks coming back, joining the fire service, and they adapted a lot of the World War II military organization to operating these large scale fires. And so that was kind of what I started out in. And then in '70, had a bunch of devastating wildfires in Southern California, and it was pretty unorganized. A lot of resources were going like this, zooming past each other. And there was lots of fire, not enough organized resources, mainly fire engines, but other things as well, hand crews and bulldozers and things like that. So the Forest Service, which some of these fires fell on the Forest Service, some of them fell on the state fire agencies and local government, but the Forest Service wanted to try to improve the system. So they pulled together a group to look at, hey, how can we fix what we're doing, because it's just not working that well. And they went to Congress, and in 1974, Congress allocated $900,000 to them to improve the wildland fire response. And then what grew out of that was Southern California fire resources were pulled together, and it was called FireScope, which is the fire resources of Southern California for potential emergencies. And so it was basically a Southern California operation for a period of time. And originally it was to address the coordination of resources and not so much to be on-scene management. It was meant to be try to get this where people are going, zooming past each other, trying to get that sorted out. But it quickly morphed into a system that was on the ground to help coordinate incidents on the ground. And primarily it was looking at wildland fire, because wildland fires are incredibly dynamic and are a huge challenge. And so when they got that bear wrestled, they could take it and use it for other things as well, which they found it worked pretty well. So anyway, continuing on, ICS continued to expand, and it became more all risk and increasing areas of the nation. It still was primarily wildland, but it was slowly getting adopted by other organizations. And when in 1989, many of you probably remember Exxon Valdez, and the U.S. Coast Guard found that they had many of the same coordination issues that the Southern California fire agencies found. And so they said, man, we got to come up with a better plan. So through the 1990s, the Coast Guard became enthusiastic endorsers and adopters of ICS, the Incident Command System, and they use it like crazy today. And then Hurricane Katrina, who was around for Hurricane Katrina? Who remembers that? If you remember anything about it, if you remember anything about it, it was the discussion about how terrible the response was. And one of the organizations that took a beating was FEMA. And it really wasn't, this is some of my own opinion at this point, but it really wasn't FEMA's problem so much as it was the local government folks were not trained to the level they need to be trained to manage an incident like this. And I can just remember seeing the helicopter airplane flyovers of the hundreds of buses sitting in a parking lot underwater down there in Louisiana, thinking, why are those sitting there with all these people that need to be moved? So in any case, the one bright spot, because the Coast Guard had adopted ICS, and I mean, fully adopted it, they were managing all the spill containments for all like the Exxon and Shell oil companies and all the big companies down there, chemical companies. They were managing that, and they did a really good job of managing it in pretty widespread operation. So it was really good. And then if you who can remember, well, you can remember just here recently, we've had that fishing vessel sink off the San Juan Islands. So we got a fishing vessel, pardon me, sitting off the San Juan Islands in 200 feet of water. And I noticed that when the paper was talking about it, they said the Coast Guard was in unified command with some of the other various agencies. And that's a ICS term, unified command. And it pulls in all the folks that have a significant interest in the event. And so they're in unified command trying to mitigate that. And then, of course, we had September 11th, and President Bush signed the Homeland Security Presidential Directive 5, which mandated a national coordination system. And that's where really NIMS came out of that, because there was a number of coordination issues at that incident. And so it proceeded along, and in 2005, they started funding with grants. And that was the mechanism. If a organization was reluctant to get involved in Incident Command System or NIMS, this was the mechanism that pulled them in. If you remember, if anybody remembers being around, if you were working in emergency services around that time at any place, there was billions of dollars of grants being allocated. And the only way you could get a grant through the federal government in this program is to say that you were in compliance with NIMS. And so myself, for instance, and a fellow firefighter I was in Northern California at the time. We have 22 local government volunteer departments, and we got $1 million grant for radio equipment to help to replace their radio equipment so we can get them all on the same page. One of the requirements was you will be in compliance with NIMS. Every grant that I worked on in the fire service with FEMA grants or US Fire Administration, every one of them says that. And so that was the mechanism that drove everybody, besides the fact that it's a fantastic system, in my opinion. It got people finally, because a lot of people don't like to change. And so it had to have some mechanism to get them to change. So, and that was the mechanism. So what's some of the common principles are terminology, like incident commander, that's a standard term. Officers, liaison, public information and safety officer, those are right underneath the incident commander. Chiefs, planning operations, finance, administration, planning, those are, that's all standard terminology. Leaders is a strike team leader. That is a standard terminology, and directors and so on. And plus there's resource descriptions for like law enforcement units, engines, bulldozers, air tankers. When you go to look at fire engines, for instance, they are typed, and the typing has a significant meaning. Type 1 engines are basically the big, what I call, if you're in the fire service, pavement queens, which is they go in standby structures, and they're a needed resource. but they're the big engines, city engines that operate when they're operating in that environment. They're type 1 engines, and typically type 3 to type 6 engines, what you see in a wildland incident. And they have those typing, that typing has criteria, which is very handy for myself. I worked in communications, and I would operate within the system ordering resources, and I was a battalion chief and a division chief, and so I would order resources when we had a fire going, and I would just ask for a strike team of type 1 engines or a strike team of type 3 engines. Well, I knew exactly what I was getting, and that's the beauty of the ICS system all the way around. Is you have typings. There's a book about, I don't know about this thick, that you can thumb through there. And if you may have one, if you're working in the EOC, you may have one. You can find every kind of resource you can imagine in there, and it's got their typing, what type they are. And it streamlines the process so that you don't have to sit and say, I want a big red fire engine that has 2,500 feet of hose and 1,000 gallons of water on it, and et cetera, et cetera. I know when I ask for a type 1 engine, what's on it. And same thing with bulldozers. They are typed. Air tankers are typed. If I want a type 1 air tanker, it's going to be a DC-10 or one of the other more recent ones. So that's some of the terminology as common principles. Then the forms we use. I don't know, any of you involved in COVID response at all with any of your agencies? Yeah, so I was involved with RDEM for 2 years doing COVID response. And we had an incident action plan, had all the components of an incident action plan. And many of these forms I'm showing you right here were part of the incident action plan, but these are in particular are of interest to radio operators, ham radio operators, because one, the ICS 205 is the Incident Radio Communications Plan. I'll show you some examples of those forms if you haven't seen them. If you've been around a while, you probably have seen them. But the Incident Radio Communications Plan gives you what you need to operate your radio on in the system. And then the Form 217A is the Communications Resource Availability, which is basically a whole pick list of what frequencies you may have available. For instance, in Kitsap County, we have a 217A, and it is full of frequencies. And so if we're gonna conduct an operation, we go to the 217A and just pick what those frequencies are and plug them into our 205. Works pretty well. And then the ICS 213 RR is a resource request form. I'll show you one of those in a minute. And those are used regularly in the EOCs. If you haven't, how many of you have used one of those? Anybody used a 213 RR? Great, excellent. A couple of you. That's outstanding. And they're very handy for ordering resources and then getting confirmation that you've gotten them, et cetera. And then there's the old ICS 213 general message form, which is basically just passing a message to somebody in your organization and getting a reply back. That's also. So one thing that's the most beautiful thing about ICS is it's scalable. So you only use the positions you need. You don't have to build out your whole organization. You just use the ones you need. Another common principle is span of control, which is 3 to 7, means how many people are you supervising? And you can be 3 to 7, but 5's typically what's being utilized. If you look at a strike team of fire engines, if you say, hey, what's in the strike team of fire engines? Well, it's got a leader and 5 engines. And a strike team of bulldozers got a bulldozer support unit and 2 to 3 bulldozers, and so on and so forth. So that's span of control, and you don't want to exceed span of control. And when you start exceeding span of control, you go, oops, I need to figure out what else I need to add to this. And then each person resource only has one boss, which is unity of command. So you don't work for 10 people, you work for one person, which is really a good thing. Anybody has had a bunch of bosses running around trying to tell you one person what to do, it just doesn't, it's not very effective. So that's a very good thing also. And by the way, if you have any questions or comments or whatever while I'm talking here, just kick them out there. So it is scalable. So like in this example, you got an incident commander with 2 fire engines. He doesn't need anything else, doesn't need any big organization, but as things start to grow, we might add an operations section chief and add some more engines. And so it keeps adding engines. And so what's happening, he's going to start exceeding his span of control. So now, and he knows that. So he's added an operations section chief. And they're going out from underneath the IC directly, and they're moving over to underneath the operations section chief. And so now in this example, the operations section chief is supervising the 4 engines, and the incident commander is only supervising the ops section chief. Works pretty well. And that's how you scale the organization. Just one example. There's lots of different ways to do it. And this is this would be a full-blown ICS organization. I'm sure you've all seen these charts if you've been around a while, or these org charts. But again, if you're looking on here, like these public information officer, liaison officer, safety officer, those are all specific terms and titles. And logistics section is the logistics section chief. Planning section is planning section chief. DMOB unit leader down here, resource unit leader. You get down here, it's air ops branch director, task force or strike team or single resource, division group supervisor. All of these are specific terms that fall within the ICS structure. And I encourage you, if you are going to be involved with emergency management in some form, that you do learn these terms. There's the quickest way for someone to find out that you maybe aren't savvy on ICS is for you to come in and say, hey, where's the planning section leader, or where's the finance administration commander? Because they'll get you pointed in the right direction, but it just shows, hey, you maybe need to know a little more about it. So where does communications fit in? That's right there in the communications unit under the logistics in the service branch. Typically, you'll find it if you have a large scale organization. This would be we had, I would say, most of this filled out for our in our EOC with for COVID response. And I should say some EOCs use the ESF model, emergency support function, which they break their EOCs into emergency support functions. And I don't know what you all are using, if you're using that or you use the ICS model, but we use the ICS model, works pretty well. But the communications unit falls under the logistics section. Now, does that mean that your communications folks can't be somewhere else working within an organization? No. For instance, we had we were doing a community-based testing site early on, and very early in the response, and we had National Guard resources, a Navy person, local government resources, CERT folks. We had all these people. Well, and mostly it was an operational thing. We did have some planning, but it was mostly an operational. We did have some logistics. We did have some finance requirements, but our comm unit was working basically in the operations section, getting that communications up and running. And so I had one of my folks as a comm unit leader. So I said, hey, I need you to come in and build me a 205 for our operation, because we were kind of spread out. And this is another thing you'll run across. We weren't using amateur radio for the most part. We were using FRS and MERS and things like that. And so I encourage you to also understand that, yes, amateur radio is a fantastic tool, but when you're close in like this, and you may not have every person has a amateur radio operator at their disposal, you can use an FRS radio. And he took the 205 He's a ham. Mike Montfort, you may know him, may know his name. He's a ARES guy. He came in and built the 205, which was great, and it had all the FRS channels. National Guard was using it. We were using it, and it was not that spread out, but it was spread out enough where we need some radios, so it worked well. But in that case, he was working more over. We didn't really have a logistics section set up, except maybe for a food unit and some supplies and facilities, but we didn't full-blown service and support branch. We did not have. And so he was over really supporting the operations branch, and that can happen. And I would just caution you not to get caught up in if you go to an incident or something stood up and someone says, "Hey, I want to put you in I want you to go over to the planning unit to help them out with something." Well, I'm supposed to be in the logistics section. Well, or I'm supposed to be working with the comm unit. Well, you may be, but you may be asked to do some other things. And that happens. And typically, if this were a full-blown incident, like I've been on many of them, there's always a communications unit leader, and there's communication comm operators and Oxcom folks. You all familiar with those terms, Oxcom and so on. And you may be asked to go into the communications unit, and they're operating some public service radios, or you may be asked to use your amateur radio frequencies to pass message traffic. We're going to be doing a lot of that in the event of the big earthquake that if we're all around for, which I hope I'm not. But if it does hit, we're going to be using a lot of amateur radio frequencies and passing messages via amateur radio. And that's why I think it's really important for people to understand the system and be good radio operators and so on. So any questions so far? Have I confused anybody? If I bored everybody out to tears? Okay, I'm not boring anybody to tears, I guess. So I'll keep going. I don't have too much more to go. So this is, I said there were some forms. This is a 205 communications plan. And so this would be the document that, who's seen this? Who has seen a 205 before? Marty, you've seen one. Bill, you've seen one. Okay, good. So for those of you that have not seen one of these, it's basically you put in whatever the incident name is, whatever was prepared, and what the operational period is. Every incident's going to have an operational period, and it may be 8 hours, it could be 4 hours, 8 hours, 12 hours, 24 hours. You never know. Or in our case, once things started to slow way down with our COVID response, our operational period was a week, which can be as well.
Hey, Doug,
Yes, go ahead.
this is Ray Smith. I'm just going to quickly say that I was introduced to 205s and 213s during the exercise. I was a total newbie to it. Steve and Mike really helped me through it. They are a fantastic tool, but if you've never done them in a disaster exercise before, there's a learning curve, but fantastic tool.
Yes, there is definitely a learning curve, and I encourage everybody to, and thanks for that input, by the way. I encourage you to, if you're doing an exercise, use these tools so that you can get more familiar with them and understand what needs to go in where. It's fairly straightforward, but there are some little nuances with it. And the nice thing about these forms, if you pull them offline, and you're just like, what is that function supposed to be? Well, you can go, it's like there's another page or two behind it that'll give you, this is what the function means. And so that's very handy. When you build out when it's not very handy is when you're trying to include it in an IAP and you don't want all that extra stuff in it. So you got to pull that out of it. But for building it for the first time, it's a great tool. So yeah, so that's the 205. So then there's your general message form. And over here, you've got your 213 RR for order and resources. And there's a lot of there's a lot of approvals that go along with the 213 RR, but if you are in a place where you're being expected to pass this information, just pass it verbatim. Unless it's just like something that just totally blows you away, you don't understand, but because there's a lot of approvals that have to go into it. You can see the section chief, like the operations section chief wants to get a particular item. He's gonna request it and then he's gonna sign it or the person requesting it's gonna put their information in. He's gonna say, yes, I agree with that. I want you to get that for me. And then it goes all the way through the system. You get probably finance and admin involved in it. Once in a while, ours I was in operations for much of the assignment. And every once in a while you'd ask for something, maybe we'd go through the system and you're like, where did it go? And so you'd have to go do some follow-up to find out where it went. So, but it'd go to logistics and then it'd have to go to finance for approval. And sometimes it get lost in people's email, and that happens. And you just have to follow up on it. Any questions about that?
It sounds like it's real lengthy in the process, which probably would not always be a good thing.
Yeah, that is true. Yeah, it can be. Yeah. Anyway, it can be pretty difficult to get the information all pulled together and identify what it is specifically you want. So this is where, when I was talking about, gosh, it's nice to have typing of resources. This is where it really helps to have typing of resources, because if I wanted to, I could put up there where it says quantity under 4. I could put in, I want 1, and what do you want? I want a strike team ease of strike team of engines, right? And everybody knows what that is. And the type is a type 3. And I don't need to say much beyond that, because I don't have to spell out any detail. I don't have to detail it, because anybody receiving that on up the line should know what that is. And then it gets sent up, and somebody fills that request. I used to do this a lot when I was when I was working in California. Part of my job was going in and being a supervising dispatcher, because I also dispatch. I did a lot of stuff in my career, and one of the things I would do is this also is making sure that things were going to the right place and getting back to where they needed to go. So it was a fun job. I had a great time doing it. Yeah, so that's enough on that. And then the activity log. Who's filled out their activity log? Yeah. Hopefully you've all filled out an activity log. That's the thing that tracks your activity on an incident. And when you had an incident going, and I would get yelled at periodically during the COVID thing, because I'd forget to turn my 214 in, and the plans chief would get on my case about it, rightfully. But it's the documentation on what happened on the incident. And so it's very important to fill it out. We tweaked ours a little bit to make it a little easier, because I was using the same people in many cases, and doing the same activity for part of what I was doing. So we tweaked our form a little bit, but the 214 is really important. And I really encourage you to take some time and fill it out. If you're on an assignment and you're doing a shift, get your 214 out, get it started right, and keep it up like a diary. And at the end of the shift, you're going to turn it in. And then everything that is all gathered. Our plans chief at our emergency management was pulling her hair out trying to get all the 214s and all the documentation pulled together at the end of when we finally stood the EOC down. It's still kind of going, but not like it was. And so she pulled together all the stuff for the records, because why do you need those records? Why do you suppose? Money. Because what happens is, yeah, so Yeah, so what you need, so what's gonna happen is all of these things are gonna be submitted to FEMA. They're all submitted, everything's submitted to FEMA for reimbursement because they were paying for a lot of this stuff, through grants and the allocations. And so, and FEMA will come and audit, and FEMA did come and audit. And sometimes they do it through their regional offices, but they will audit. And so if you're looking for going back, trying to confirm something, you said you did something, did you actually do it? Yeah, here's my 214 from my operations section chief, where he identified, wrote it out and said what he had done. Oh, good, great. Okay, we'll pay for that. And that's a big deal at the local government level, huge deal when you're talking about local government. So anyway, that was just some of the forms, and they were probably the ones I would consider we want to most think about as amateur radio operators, making sure they get done and or be familiar with them. But the 213 typically wouldn't be found in the IAP, but the other in the incident action plan, but the other forms would be. And it can be pretty thick. The IAP can be pretty thick. If you looked at some of the wildland IAPs from these fires we've been having all over the West, they have a lot of documents, and they're doing them every 12 hours or every 24 hours. They're putting a package together to get out to everybody. It's a big job. Planning's a big job.
I had a question, John, put it into chat, the 309. I know WinLink generates 309. How have you used that?
The 309, remind me what the name of that form is.
It's
again?
more of a communication log.
Oh yeah, communication log. Yeah, I was having a little old age brain thing. Yeah, the communication log, we use it like a log, login communications, like when we have net control duties and workstations for our exercises, and we've got our amateurs out there operating. We use it for that primarily. It works pretty well for that. I'm trying to log their information. Thanks for that. I can't see the chat info, so. Well, I guess I can see the chat info if I click on it up there. Anyway, you think I'd know how to do Zoom a lot better. Yeah, so if you haven't taken the IS 100, 200, 700 courses, those are the basic courses recommended for just about everywhere I've been involved in. Just so you have a good understanding of the ICS. And there is, the IS stands for independent study, and FEMA has 1 million independent study courses that are around ICS. Windshield survey, you want to know how to do a windshield survey, they got a course for that. They have courses for everything. You want to know how to stand up an EOC, they probably got a course for that. They have tons and tons of courses that I encourage people to check out. They're really good, but IS 100, 200, 700 are pretty much the basic that you probably should take. And if you really, if you decide, well, I'm going to be in the EOC as part of the incident management team, then I'd say you want to start looking at taking IS 300 or incident ICS 300. They don't give that as an IS course, but so ICS 300 and maybe 400, although 400 is like, to me, too over the top, but I teach both 300 and 400. Is there another chat thing I've missed here? Field guide. Oh, thank you. NIMS ICS field guide. Very good. Yeah, there is a lot. I'll tell you, one of the best ICS field guides, NIMS field guide, is put out by the Coast Guard. Has anybody seen that? Anybody use that field operation guide? It's really, really good. They put a lot of info into it. And I see an ICS quick reference PDF. Thank you so much for that in the chat. Yeah, so, and then my final thoughts were, so if you're gonna, basic rules for amateurs assigned to incidents, and this is, just my basic kind of rules. Look and act professional. Many of us have seen the folks that show up and are less than, and you'd prefer that they wouldn't be less than. So just looking at professional, if you're passing traffic, do it verbatim. Don't try to change the meaning of it, because you're just passing it through. And in some cases, if you are a shadow person would be somebody who's an amateur radio operator who's been assigned to, say, an op section chief or the incident commander, and you're a shadow. Sometimes, to me, it's more expedient to just let them do the communicating while you stand there. In other words, you make the initial contact and say, I've got a message for you. Here's the IC. Hand on the microphone and let them make their call. You can do it that way. It's perfectly legal to do it that way. And I recommend it sometimes because they have specific things that if you're not familiar with them, you can jumble it up a little bit. So anyway, just a thought. Do not self-deploy. You hear that a lot. Don't go running out to the incident because you know there's an incident, I'm going to go out and help. We don't want that. And you may be asked to do something that's maybe not quite amateur radio related, like I was talking about earlier, which is like FRS or MERS or setting it up. We also did a drill, drill here about 2 months ago, and for sheltering in place or sheltering, and we had a lot of people out there, and our CERT folks, a lot of your CERT folks use the FRS radios, MERS radios. Yes, ours do too. And so we tried to get everybody on the same page. And so that's kind of what we built out as FRS and MERS. And then I was there as more of an observer, but I had some other folks and we were using amateur frequencies. So you can do it either way. Just put it in your 205 and say what you're going to do. And then try not to insert yourself into discussions on the plan unless you're specifically asked. Some people will come in and start wanting to, hey, I think you had to do it this way. Yeah, okay, well, thanks very much. But anyway, that's pretty much all I have. Do you have any questions, anybody? That was kind of quick.
I was just curious. I've taken the ICS courses because I did CERT and EMS and fire. So I've done those. But are there any ICS IS courses, the FEMA IS courses, specifically for amateur radio? Like something for communications or something that would enhance the amateur radio side?
I'm going to say that there are lots. I'm going to say that there are lots of related things. I'm trying to think if there's something specific. Maybe one of the other folks on here knows.
Yeah, the one I'd recommend that's a taught course by FEMA is the OXCOM course.
The OXCOM course, yeah, that's a good course. Yes, I agree. That's a really good course. We have held it in Kitsap, but that's not an IS course particularly. It's an in-person class. It's been done. I know it's been done over Zoom, but I just don't know how effective that would be in a Zoom environment. But yeah, to answer your question, Kathy, I'm not 100% sure that there's a specific one, but there's tons of related courses for sure. Any other questions?
I also put in the chat OregonAces.org.
That's another good one.
They are really, it's not ICS, but it's, I would call it intro MCOM. As soon as you get your license, if you want to get into MCOM, that's a super good class to take. I've taken the beginning class twice, and we have some instructors here in Seattle that are capable of teaching it. I don't know where they're at these days with the COVID situation, but I think they were attempting some online versions of the class.
I can speak to that as one of the instructors.
Thank you, John.
Yes, we've done a couple of online courses. They are not as effective. They're certainly much more difficult logistically for us to put on, because one of the benefits of the Oregon ACES class is that with each module of discussion, there's a practical hands-on portion that's done, programming radios, things like that, which, trust me, is not easily done via Zoom.
No, I'm sure not.
It's when you have somebody program and hold their HT up to the camera and press the push to talk to see if it shifts frequencies, it's very time consuming and cumbersome to do, but we have done a couple of them. My understanding from Scott Honaker, who kind of runs all that up for us up here, is that we're looking at going for an in-person course here in the fall, but no dates yet determined.
That'd be great. I would love to take it again, and hopefully you guys will come up with an intermediate one of these days.
Well, they're working on, well, they call it advanced, but they've been working on it, for I don't know how many years.
Yeah.
So
Well,
it's
COVID
not
kind
going to
of
be
put
soon.
everything off.
It won't be soon. I know they are working on it, but a way to think of it is take Oregon ACES as your first step, and then work up and take the Oxcom course. It
Yeah,
would be a good
I
sequence
like that.
in which to do them.
Yep, absolutely. So, yeah, I got a little off ICS topic, but this is good. I appreciate that, John and Bill, because those are really good classes. And I've been trying to get one again in Kitsap. We've put a couple on, and my understanding is that Scott is rewriting the Oregon ACES manual. And he's pretty far along, but hasn't finished it yet. And that's what we're waiting on. And you may know about that.
Yeah, it has been revised. It has gone through its final proofreading.
Great.
He is looking at doing it as an on-demand, Amazon on-demand publishing type of situation to save costs and storage requirements. And I know that's in process. I expect that's going to be available pretty soon.
Cool.
Okay. Yeah, I keep talking to Monty Monty Simpson about getting the class, because I really would want to put it on again. And we will have one here in Kitsap, I'm sure. So we'll put the word out if we do, if anyone's interested. So anyway, that's really all I have ICS related. And unless you got more questions for me or comments, I appreciate your time and enjoyed doing it.
Thank you.
You're welcome. I'm going to stop sharing my screen. Here we go. And I think that about wraps it up. Unless somebody has anything else.
Well, I was just gonna ask the same thing. Steve, how things go tonight for you?
Ask the question again.
Oh,
I'm
no,
asking Steve.
no, it went a lot better. It was a good night. I
Okay.
followed up pretty good. I'm starting to pick up a little bit more and more.
Okay, Kathy, how did it go for you?
I thought it was good. Even with the ICS, I'm familiar with ICS, but I wasn't familiar with any of those comms forms. So that was, definitely helped a lot.
And Ray, can you put that on? Same question, how's it going?
Well, okay. I think I'm going to jump on out of here then, you guys. Thanks a lot for your time.
You haven't heard anything. Ray, is he there still?
Is who still here?
Is Kurt still there?
No.
Okay, I was gonna ask him how things went, but that's okay.
Yeah, it's 82 degrees in the room here and stuffy and muggy. So as soon as he could, he made a run for it, and I'm not far behind him.
Yeah, we got a 94 outside here now, but so we can go ahead and stop the recording and shut her down, like for everybody to show up next week. Thank you all.
Thank you.
Thank you. 7-3.
Thank you again. It was great.
You're welcome.